Matlab is a commercial software widely used in many fields, including science, engineering, economics, and biostudies. Today, we're going to talk about how to use this software to do some plotting. In the part one, I will talk about simple two-dimensional plot without color option. In the part two, more color field plotting will be discussed. So just some basic stuff for you have some idea. I know probably most of you guys use Matlab already, and just a small review. So Matlab is like Python and R is a programming language. However, and you can use it for many computation simulation. However, different from Python or R, you need another software, graphic software we call it GUI, like Spider or Jupyter Notebook for the graphic interface. And Matlab already included that, which is good. And the Matlab is no cost for all UCL users, and it's also available on Hopin2 cluster. So once you log into Hopin2, you can just type module available Matlab, and you can see many different versions of Matlab. I think it's probably the latest one is 2020 alpha, I guess. And you can launch it interactively by QRSH or just submit your mjob, the Matlab file. But here I want to mention one thing is Matlab requires a lot of virtual memory when you launch it interactively. So when you do the QRSH, please request a little bit large memory, like 16 gigabytes or even 32, especially use the later version of Matlab. So you can find more information on Hopin2 website. You also can install Matlab on your personal desktop and laptop, no cost. And if you only install the basic stuff, Matlab only take probably 5 gigabytes space. But the good important things for Matlab is that including a lot of library. If you need to purchase it, I mean, we used to purchase it. A Matlab company charge every library one by one. However, now everything's no cost. So if you have the space on your hard drive or desktop, laptop, I would suggest you install all the library. Instead of you write your own code, you can just probably type one command that do everything. So, and I designed some example for this presentation that were all available on the GitHub. So after this, you don't need to write it down. After this workshop, I will send out the email, including this link and the presentation slides. So let's review some basic Matlab plot interface. When you open the GUI interface on Matlab, this is the example one, you can see right over here. So you don't need to exactly write the script, you can just type everything on the command window. And after you type something and you run it, you can see the variable on your workspace. Okay, here if you select any variable, we say E1, and click the plot on the corner here, okay? And it will pop out all of the, sorry, there is a chat. Excuse me, download Matlab. Actually, you have, sorry, I just tried to answer the question on the chat. Actually, I will offer all examples, so you don't need to, you can run on your own laptop, that works. And actually you can, and currently the PowerPoint slides you just see will be exactly the same. So you don't need to, well, you just listen, yeah. So let's back to the slide. Oops. So once you click the plot, you can see all of the option, the plot option, you can see if you scroll down, something like this, okay? And you can see some color, some are with the colorful and some are great, like this one, the arrow bar. This means that you're, oops, there's another question on there. Oh, thanks, Sachin. So for this one, the yellow bar with the dash line, this one, which means that your variable is not appropriate for this plot. you cannot use it. However, for the colorful one, like I click right over here, the area one. So this means your variable is appropriate for this plot. So you just click area, you can see something like this. So you can see in this variable, we have 21 elements. So the x-axis is the number of elements on array E1, which is your variable. And you can see all your value on the y-axis. And in this way, it's pretty simple. You can just take a simple look on your figure and what you want to plot and how you want to show it. However, in practice, I think very few people doing this way just interactively to change something, some parameters or property on this figure. Most of the time, no matter you use the Python Jupyter Notebook or Matlab, we try to write all of the plotting command in the script. This kind of way is provide more control for a specific property. You can change your figure and the plot. So when I use Matlab, usually I try to separate my computation and the plotting into scripts. For the computation, you just save the output and use another script to run it. Otherwise, it's really hard to control which part gets something wrong. So for the plotting command, for most of the command that you use in Matlab, you just one plotting function like I show right over here, followed by a variable. The variable like the previous slides E1 and the property. For the property is your figure property to control it. And the last one will be just one value to control this property. For example, if you want to plot the previous slides, like we just type area followed by E1, and you got exactly the same what you show by interactively running. However, if I want to change the figure, saying I want to change a figure like this way, there is one more question on the chat. Are those variables? No. I can type. No. Okay. So we say E1, okay? And you want to change it, saying I want the rate color, I want to make a line thinner, sorry, it's bigger, or I want to make a dash line. So you just need to specify the property. So you need to know the name of the property, saying like this one, okay, I want to change the face color, which is area color. I want to change the line style. I want to make it a dash line. And I also want to change the size of the line width. So what you need to do exactly just write one line. We say I want area E1, a face color with R, which is red, and I want to change the style as dash line, and I want to change the line width. So most of the commands like this way is pretty simple, so you can control easily on your script. So here I want to mention one thing. I think besides Matlab, more and more people using Python, which is very powerful. I use as well. And in Python, there is a one big library, a package, a library node. It's called matplotlib library. Actually, if you take a look at this library already use it, you'll find it's almost the same as Matlab, the plot, very similar, no matter command or the structure. So here is the website, you can take a look at it. The reason I want to mention this because the Matlab used to, we need a license to purchase it, and Python is pretty free, including the Jupyter Notebook. So if you use this one, and that'll be easier, you can shift all of the command of structure from Matlab to Python and use it. Sorry, here is one more question on the chat. Okay. They're different. Probably, sorry. Probably, I didn't. Maybe I should answer the question after all of the question on the chat after the presentation. And otherwise, it's just interrupt a little. Okay, so for this one, and for some of you guys that already used the Python, I just tell you that in this workshop, I will list the same command. You can plot the same plot. I will include both the MATLAB structure and including the Python command using the MATLAB plot. So for this one, you just need to import in the Python. You just need to import the MATLAB library as a plot. And here I import the NumPy because I want to create one array for X. And for in the MATLAB plot library, there's no area. So what we need to do is we use the field between this one. And then you can see the same option of property name, called face color R. So you can get exactly the same picture on the right. And another thing is you see the dashed line at the boundary of this area. Actually, in field between, you need to write separately when you use the matplotlib library, but in Matlab, you can just include it in the line style. So here, the last 4 line is just to find the 4 boundary of this area. Okay, you can see the similar thing in the later slides. So let's start from the very simple 2D plot, which many of you already know. We just try to review it. So here is example 1. I want to plot the exponential function. Here, I use the x to find the grid size, and I plot x, y. So you can see the 4 line. What I need to do is just plot x, which is the x-axis, and the y1, which is the first line, and the line style I wanted the solid line, but the second one I want the dash and dot line, so you can see the difference. Here we don't specify color, and MATLAB automatically generate different color for different data. Then we use the command x label, and to add x, you can type whatever you want. Right over here, you replace x, and the font size is the size of x. You can see the number. If the number is bigger, the size is bigger. I will explain the unit later on. And here is the label y. So you just need to type label y and put the y right over here, and the same thing. And you can also type you can also add the title. The title I add right over here is the function y equals potential, and the font size is a little bit bigger, and you can try to do the same thing. And that was simple. However, we try to modify it a little bit. And here I want to mention that here you can see the green box. If you see the green box, the blue box, the light blue box, right, you see over here, or later on you will receive the slides. Those are MATLAB's command. And if you see something in the green box, this is what you can use in the Python using the matplotlib library. Okay, then we can add something more to the figure, saying I want to add a color. So after you put the variables and the light style, you can put a color. I want the color as the red, and I want to make the line width a little bit bigger. And we also can add some grid on it. So what you need to do is just on the MATLAB is type grid on. And we can also add some regions to represent all the plot, okay? And for this region, you need to know the name of all your variable, what you want to show it. And here I want to mention one thing is location. Location is the location of this region box right over here. So here is the northwest inside the grid. The default is inside the grid if you don't know how to type anything. However, you can change it to put another property to make it outside of the region. And you can put the font size, which control the size of text, inside this region box. The same thing for the Python library, matplotlib library in Python. The grid, you just put plot grid on. No matter it's true or not, you can just put over here. If you don't write anything, just put the grid on it. However, for the region, it's not inside the category of the plot. Here the AX, I will explain something more later on. Here AX means you control the axis of your plot in Python. So we can add even more, more thing on your plot, like a marker. Addition to the dash line or solid line, here is double dash. I just try to save the space. It's something you already seen in the previous slides. You can add a marker. Here I want a marker circle, and you can change your marker size to 6, which is this unit is point. I'll explain something later on. So, and the marker face, which is yellow, and you can change it. Here I just list some useful marker we use in the Matlab, like a circle, plus a star or dot, cross, those kind of things, and square. And that will be the similar for if you use Python matplotlib library. And actually, Python matplotlib library offer even more marker you can use. So I cannot list all of them. So here is the website you can take a look at. But you can see the command almost the same, just a, just a marker symbol is a little bit different. All right, so for many data, we probably have some confidence or error, especially for observations. So we want to plot the same thing. So we want to plot the same arrow on the same data. Here we don't use the plot. We don't exactly use, we say plot one line and add another vertical line on it. We can just use the arrow bar. So if you use the arrow bar, the rest of the property exactly the same. What you need to do is just exactly add one variable arrow on it, okay? So this is the basic 2D plot, and usually we want to use multiple, the same Matlab library, you can use it. Usually we want to change the data in different scale. We know, especially in visualization, especially when the data size or scale is change very big. So you can use the simulog to change log, to change x-axis with the simulog x, the same exactly in the variable you want to put on and the properties. The only thing to use this command is to change the x-axis log scale in one direction, only in x-axis, and the y keep it linear. So you can see the green box is what you need to do in Python. So the same thing, if you use a simulog y, then you only change the y-axis to log scale and axis keep it linear. Of course, you can do the same thing for both, which is log, and you can get both x and y in log scale. And you can see that most of the command you use the matplotlib library exactly the same as the Matlab, the gray box and the green box the same. Okay. So those kind of those plot is pretty easy and easy to use. And sometimes in one figure, we want to put multiple plot or multiple data. So in that way, we use the command subplot, which means you divide the entire figure on your screen into an n by n grid. Okay, so like the figure you show over here will be actually I make 3 rows and 2 columns. So for this one is the 3 by 2. So the entire figure will be 3 by 2, and this is the first one. So this is 1, and this, next to the right of this first figure will be 2, and there's the third one and fifth one. So to doing this, what you need to do is just exactly on your plot command, no matter what you want to write it, just add a subplot 3 to 1. Like this data, this is atmospheric, it's the weather data in one station. So you have relative humidity on the top, and the middle is temperature and the pressure, and in the bottom. So that kind of plot is easy. However, if you have 3, you can use subplot. But if you have more, we say 10 or 5 or 6. If you're gonna use this kind of things with subplot, and your script is gonna be very, very long. So for those data, sharing the same x-axis, there is another command you can use and try to do once. So here I just put the subplot 1 to 1, which means I only have one big column on the left of my figure. And what I need to do is just try to make all of the variable. So I have, as I said, I have relative humidity, I have temperature, I have pressure, I even have more data. What you need to do is just make a table. So here, later on, I will give you some example how to make the variable or array as a table. So if we use the Stackedplot, you just put the table name over here, and the table will share exactly the same x-axis, which is time, right over here. And you just need to do the Stackedplot and put the table and what you want to display here. If you take, as I say, you can download all example on the GitHub. So you can, I just cut the most important part and show right over here. And you can read the rest of the script. So here I want to show the Y label, which is the relative humidity, temperature, and pressure. And I specify the font size over here. I put the title in the command. So by this way, I just have one line, and then I can show most of all of the figure. The only thing is you need to change it. If you want to specify, Matlab automatically generates some color or another marker, but the color for your line. But if you want to specify each data, like here, I want to change the relative humidity as the circle marker. So I just put the marker. Actually, you can see all the three are circle marker. Then you don't need to specify 1, 2, 3. So here, the line property 1 means the first data, and second data you just need to change 2. And if I put color blue, then the relative humidity become blue. So you can see on the screen here is 2 and color is red, then the temperature become red. For in this way, you don't need to exactly to see which subplot you're gonna do. What you need to do is just change the order in your table, and the Matlab use this command. The Matlab will automatically generate that kind of plot share the same x-axis. Okay, so we can use this kind of basic command to refine our plot, and for our no matter the presentation or publication. So here's the example. And I'll also including this example data right over here so you can use it. So if you load this data including some basic data set that we always use for our presentation or research, whatever. So this is original observation with arrows. So you can see the arrow bar, and you can see your fitting curve if you do some regression. And you have the model prediction, which is like the bumped lines over right here. And you can have validation data, and you also have the confidence interval. So if you don't specify the light plot property and you plot like this way, it's really hard to read. So what we need to do is just try to use the previous command to refine or do some plastic surgery on this figure. So the first one is we change the color. You can change the color on your arrow bar as the black, and you can change the fitting curve, and you also set a marker for the validation data. And we can also use the different line style for your model prediction and the confidence interval. And the entire figure looks a little bit more clear. And we can add it a little bit more, something like we change the marker H color. Now the mark H color, if you don't specify it, will be the same as your line color. But here you can change your mark H color to more or less to visualize the marker. And you can also change your marker face the inside the face color and H color to show the differences. So here the face color is gray, and the H color I think is a little bit dark gray, I forgot. And the line is black. And you can also change your marker size for your validation data, which is easier to see. Here you can add some legend on it to make the product looks much better, and also add the text for your product or like fitting curve or your model prediction. So here I want to mention one thing is you can see here is some grid letter. So for Matlab, because this is very big table, so you have to take a look at the website I list over here. There is some special characteristic for grid letter of the sample you want to use. So those, like if you want to type alpha, So you just need a backslash alpha and put it in the text, or you put it inside the command. So the same thing for Matlab Power Library, and also Matlab Power Library also including you can exactly type the mathematical equation inside the Jupyter Notebook or on your prod. So if you're interested, please take a look at this website and you can find more of the information, how to type those kind of things. So the last step, we already have the refined product. The last step, we want to make the axis look more professional. So you can refine the x-axis. So to doing so, you just need to change. You can for change the axis, you are not able to write in your plotting command or plotting function. You have to use the very important command we call it set, which means you set something after the set command. Here the GCA is a control. The GCA means the current figure. You can change the current axis. So you can change the current axis. So which means you see these things, and I change the GCA, I change the current axis on your figure. Here I want to change the tick direction from the inside to outside. Or default is inside, I want to change it to outside. And you can change the tick length as the point you want, and you can also show the minor one. This is the major one with the number, with the scale, and you can change the minor one, and you can just put the minor one on. So by doing so, and here, the Matplotlib library is a little bit different because Matplotlib library separate the plot and the x-axis. So if you want to change anything in the axis, you have to use AX, which is just a short name, and put the parameters. And you can see also the bold font, almost exactly the same thing right over here. You just put on it. So this is our original plot. And later on, you'll see if we refine it, it looks much better. Use a very simple command. Okay, so before we continue the next figure, more useful command, here I want to mention something about the graphic environment of Matlab. This is not very important for many users who use Matlab. However, if you want to save your figure or print out your figure for publication, this section is important because you know how your figure will look like. And when people get this figure, they fit their requirement, no matter the resolution or how clear this figure. Because Matlab including its own graphic interface, so Matlab, all of the Matlab graphic you see on your screen, it depends on your operation system and the screen, which is your display, no matter the monitor or laptop display you used. For Matlab default display resolution is 96 dpi, which starts per inches on Windows. So if you use Windows, this is default, and this is readable. I think I forgot which version. After which version of Matlab, you are not able to change it anymore. So the default is 96 for Windows. However, if you use Mac OS, that's 72. So what you need to, if you want to see the information, you just on the command window, you just type get 0 and screen pixel per inch. Because I'm using 30 inches Mac Air with OS Catalina, so I only see 72. So, but the size of your screen, what do you want to show on your screen? Because usually we see all the figure on the screen, then we print or save it out for the figure we want to use. So the screen size is not depend on the Mac. The screen size or display size is depends on your operation system. So I'm using the 13 inches Mac. So the best one I can use is 1440 resolution by 900 pixels. Okay, so here we talk about all of the unit in pixel. However, Matlab, he got his own things to change your figure or to decide how your figure will look like. So we want to talk about the unit of the size, what the Matlab exactly see. So please remember, this is my screen, 1440 and 900. And what MATLAB see is just 72 dpi. So if we do some math, I use my screen here. This is my screen size, 1440 and 900, divided by what MATLAB see. So the answer is I have 20 by 12.5 inches screen. No, actually I only have 13 inches the MATLAB, Mac. So you can change the unit. Actually, as I change, I set the unit as inches, and I want to show the screen size. So this is the screen size MATLAB C. It's not exactly your screen size, okay? So that's a little bit different. So MATLAB use another unit we decide in our previous marker size or the font size or text. We call it point. So for MATLAB, each one unit is 1 point, and 1 point equals 1/72 inch. So the thing is, if we say I want my x-axis or x label equals 20 points, then you just have 20 over there. So those 20 on the screen or on your figure will be 20/72 inches. Okay. However, when you save out the figure still use a pixel. So when we save out, we say I want to get the current figure. So the GCF, I want to get the property of the current figure. I want to know the unit is the figure. So when we plot something on the MATLAB figure, we use the point to decide how the object will look like, how big the object is. But when you save out the figure will take as a pixel. Okay. And you can also change your unit to inches. Then you can see that the unit will become inches if you type it, I want to get some information. So the reason you want to MATLAB use the pixel because the pixel is connected to your paper size. So when you print out the figure, you can see the later size, the figure uses a later size paper to print out something. So there is a connection between the paper size and the pixel, okay? So you want to get the paper size. Even there is no printer, you don't connect your laptop or desktop to the printer. But when you print out the figure, the MATLAB will think that there is a printer. So there is a default for the paper size or the printer size for MATLAB to print out. So the default size is the paper size, you can see the 8.5 inches by 11 inches. And you can change the paper unit as a point as well, so you know how big it is. Once you change the paper unit to point, that will be exactly match what you want to see on the figure. Actually, I understand this is a really complicated. So later on, when I talk about the section of how we print out the figures, I will make it much easier. You just need to change the resolution of your figure or change how big you want to see exactly on the paper to plot your figure. And the rest of the thing will be automatically changed by the point. So you don't need to worry about it. But sometimes when we see it, what I see on the screen is a little bit different when I print it out, and why the resolution is different, because those kind of setting and other setting I want to talk about by the end of this workshop. So we can make it consistent what exactly the figure you want to see on the screen will be exactly the same as what you printed out and fit most of your requirement. So let's continue the plot. Some useful comment. And for many data processes, we want to see the data will look like. How the good thing for MATLAB is MATLAB has some default function you can use to compare your plot. Like here, I show the gamma distribution. And in gamma distribution, you only have two variables, one the scale and one the shape. So you can see if you specify the scale and the shape parameter, you can see the gamma distribution like this one. This one, you just need to plot it, the gamma distribution. So here, you have the gamma distribution. I specify gamma distribution PDF. I need to specify the x, how many points I want in the x-axis, which are observations. And I just need to change the shape and the scale, and I can plot it. And The good thing for Matlab is Matlab including many different default built-in functions like gamma distribution or normal distribution, even Poisson distribution. Not many people use it, and you can make your own distribution. So to plot those kinds of data, I think most of people use the histogram, which is most common used function we plot the data distribution. However, like example 4 I list over here. However, if you just plot, you can use the Matlab built-in function histogram, and I just type y. The number 10 means how many bins you want to categorize your data. If you just use this command, it's really hard to compare your data size or know the statistic compared to the previous slide. I showed the default built-in distribution. So what you need to do is, if you want to know the probability, you use the same command histogram and you normalize your data and plot the probability. In this command will automatically take your probability for your data, so you can see compared to the previous slide, the blue and the color will be matched. Sorry, I need to back a little bit to match your default distribution, so you know the statistic of these things. Okay. And for Matplotlib library, the same thing. You just put the history instead of histogram. Actually, Matlab used to use only hist for this command, but later version is changed to histogram. I think you still can use a hist in Matlab, but just get a little bit warning message. Okay, another one. So here is another example saying we have a data set for a small car categorized by the number of the cylinders, horsepower, mile per gallon, acceleration, and manufacture others. So if you plot something like this, we can just use histogram to plot it. I say I want to categorize by cylinder, 8 cylinder, 4 or 6. And you can download this. All of the data set is including on the GitHub. You can download. So this is histogram. I can category by horsepower, and change category by MPG. Another method we can show the distribution is the scatter plot. Okay, so for the scatter plot, I have two variables. I have the MPG, I have horsepower. Then what you need to do is just scatter, use the scatter plot, scatter, and change the horsepower. To put the variable horsepower, and I only select the cylinder equals 8, and I have the blue dots right over here. So for those kind of plot, is if you want to show all the information, both the scatter plot and histogram in the same figure, you need a subplot. It's a little bit make the figure look complicated. So Matlab offer another option. You can combine those information in one figure. Here is a Matlab library function. And for this one, we call it scatter histogram. For this kind of information, you can put the most of the information, both histogram and your scatter plot in one command. However, the same as the stacker plot we used before, you need to put a table. So here I have the array, saying I have array of horsepower, I have array for MPG, I have array for cylinder. So you just need to put these three variables inside this table command. So you just type table and put those three array on it. And once you make a table, you can use this scatter histogram command. You just put the table name over here as a table. And what I want to plot, I want to plot the MPG versus horsepower. So here I just saying I want to plot horsepower, I want to MPG. How we categorize, how we group it, you just put the group variable cylinder. That's why you need the third column right over here. And I want my histogram number of bins exactly the same as previous slides. So I have the number of bins right over here. So by this command, you can put most of the information in your figure, which is easier. and easy to read. Of course, you can add something on it. You can add a grid on it. You can add other color on your histogram. You can make a face color as well if you want. The important thing is for this command, you only can use a table. So the pre-requirement is you need to put all the data as a table by the table command. Okay, the third plot we use to show the distribution of the data would be bar plot, like what you see over here, the COVID-19 cases in California. Okay, so for this kind of information, what you need to do is just a bar. Okay, bar the command bar, and you showed here. I see the daily case is because in the previous in the script you can see I do some pre-process to deal with the data. So I just show the date, which you see the x-axis, and show the data. Here I want to mention one thing is very useful for your plot, because when you plot something out, the solid surface, solid face is a solid color. It's pretty dark. So, and it's hard to see other information. Saying right over here, the bar face is a blue. And then the 14 days moving average is also blue. So if you show two things in the same figure, it's hard to see. So here I changed the face alpha for the bar plot, so half of that. So it's become a little bit transparent. It's easy to see. And one more thing is for those kind of plot, you can add more information. You can apply most of the the command you see previously to here. So here I want to change the scale. I want to only change the Y scale. So I can change the Y scale log. So I can see the confirmed case, and that more or less makes some sense, and I can compare it. If you don't do this because of the number of deaths is much less than the number of confirmed cases for COVID-19, so it's hard to see. And for Matplotlib library, exactly the same thing, and you can apply the same face alpha to this command. But however, sometimes for those dense data, for individual case, which is one bar, is may not very important. The important thing probably just 14 days, the moving average. So here I would suggest instead of using bar for more clear presentation or visualization, because each individual is not important except those extreme data, like those dot point, I would suggest you use stem and exactly the same variable and the command right over here, you just change your bar to stem, you can see this kind of plot, or even use the stair. Here I want to mention that, and you can see this kind of things much clearer. And for the Matplotlib library, you can use the two things. You can use the step, you can use stair to get exactly the same thing. It's just a command a little bit different.